Okay, we're going to solve the long answer 1. We have two masses. It's a modified Atwood machine, so M1 is on an incline, M2 is hanging straight down. The wedge has an angle of 40 degrees. We're going to ignore friction between M1 and the incline, and both blocks have a mass of 5 kilograms. So we can look along at the scoring rubric here in case you need a guide for helping us solve the problem. But we're going to start with our free body diagrams for M1 and M2. Okay, so M1 has the force of gravity going downward, has the normal, force of the normal perpendicular to the plane, and then it has the tension from the string pulling it up the plane. M2 has force of gravity pulling it down and tension pulling up. And the force of gravity should be longer than tension because it is going to accelerate this way. Okay, and M1 is going to accelerate this way. Okay, now we need to define a coordinate system. So I'm going to call this positive x for M1, and that's y. And then I'm going to make a separate coordinate system for M2. Again, I'm going to define my positive direction in the way I know it's going to accelerate. So positive y is downward. Okay, so we got 1, 2, and 3 done. Now we need to sum the forces for M1. Okay, now M1 has forces acting in two directions, so we have to break gravity into its components. Okay, so if we kind of go back up and look at our forces on the diagram here, we have the force of gravity going straight down. Right, we have the normal going up like this, perpendicular to the plane, and we have our tension going this way. Okay, so my axes are set up so that x is this way and y is that way. So tension and the normal are going in the x and y axis respectively, but gravity is not. Gravity we have to break into its components, and we're going to break gravity into a component down the plane and a component into the plane, and that's our right angle there. Okay, if I extend gravity down a little bit further, I can remind myself of the geometry here. Okay, where this, then I'll redraw the y component of gravity like that. Again, this is a right angle here. That's theta. This is 90 minus theta. So in here has to be theta. So that makes my x component of gravity is Fg sine theta, and the component into the plane is Fg cosine theta. Okay, now I'm ready to sum the forces. So here we go. We're going to sum the forces in the x direction equals max. And I said positive is in the direction of tension, so I'm going to have tension minus Fg sine theta equals m1a. Okay. I'm going to zoom back down a little bit here. All right, and then we have the y direction for m1. Sum of the forces in the y direction equals may. Sorry, I should have put an x here, max. And we know that acceleration is 0. It's not going to move off the plane. So the forces acting in the y direction is the force of the normal minus Fg cosine theta equals 0. So from this equation, we know that the normal force on M1 is equal to Fg cosine theta. So that's good. That's kind of an important step. We'll box that up. Okay. And we can actually take that normal. No, we don't actually need that. Sorry. Okay, so now let's look at M2. Okay, we have just one direction of motion, some of the forces in the y. Now this is a different y coordinate for M2. It's okay. Is M2 times acceleration in the y direction. So I said downward is going to be positive, so I have force of gravity minus the tension equals m2a. And the blocks are tied together, so this acceleration over here is the same as this acceleration over here. Okay, and we don't know what that is. That's one of the things we need to find. We also don't know what the tension is. The tension's over there. Okay, but we have two equations, and so we can solve for the unknowns. So first, let's use the M2 equation, and we will solve for tension. So I'm going to add tension to both sides and subtract M2A. So I get Fg minus F2A, sorry, M2A equals the tension. Okay, and now I'm going to take that and plug that in over here. Okay, so if I plug that in for tension, I get Fg minus M2A minus Fg sine theta equals M1A. Now this actually is the force of gravity, meaning that this is actually M2G minus M2A. Okay, this force of gravity comes from the M1 equation, so that's actually M1G sine theta equals M1A. All right, so the unknown that we're looking for in this equation is the acceleration. All right, so we want to bring all those terms to the same side. So we want to add M2A to both sides. And we get M2G minus M1G sine theta equals M1A plus M2A. And we could factor out the A, that gives us M1 plus M2A. And now we divide both sides by M1 over, or M1 plus M2. Okay, so we get our acceleration is m2g minus m1g sine theta divided by m1 plus m2. And if we plug in our values there, we get 40.25 newtons. Nope, sorry, wrong one. We get I was giving you the force, we get 1.75 meters per second squared. You can check that yourself. Just plug in those numbers. Okay, now we go back and solve for our other unknown, but we have this nice equation right here. Okay, and we can plug in our values and solve for t. So it tells us that, let's bring this down over here. Kind of running out of room, but t equals m2g minus m2a. Okay, we plug in 9.8 for g, we 5 for our mass, and we find that the tension is 40.25 newtons. Okay. So now that we have acceleration, let's quickly go to the next page and solve the second part.